Hello students, let's talk about doing a conservation of momentum problem. So for these types of problems, they can take up a lot of space on the paper, but they're not any more challenging than other problems that we've done because the only thing that we have to use for this is P equals mv. So there's really only one small equation. We're just going to be using it a few times for these problems. So a couple of steps to do to make it a little bit more manageable is you definitely want to draw a before and after picture. Okay, that's how we're going to list the information. It sets up what the picture is, it sets up what the problem is doing in that picture. The next thing that we need to do is we need to find the momentum either before or after, depending on the problem. And remember, the total momentum before a collision equals the total momentum after the collision. So sometimes we find the momentum before the collision, and we use that to find something in the after part of the problem. Or we can do the reverse of that. We can find the momentum in the after part of the problem, and we can use that to find what we're looking for in the before part. So regardless of whether we find it before or after, we use that total momentum to find whatever the unknown variable is. So what I'm going to do now is I'm going to put a problem on the screen. You can read that problem, and then I'll walk you through how to do it. All right, let's do our practice problem. We've got our two bean bags and they're on frictionless ice. So we need to draw our before and after picture for this. So let's draw in our before up here. And so we've got our first bean bag, and we'll call this M1, and it's 3 kilograms. And this bean bag is moving at 4 meters per second. And then there's a second bean bag. We'll call this one M2. And this one is 4 kilograms, and this one's not moving. Notice that I'm using the subscripts to identify each of the objects. So here's our before picture, and then on the after side, what happens is both of these bean bags, they get stuck together. So I've got M1 and M2, still 3 kilograms and 4 kilograms respectively, but now they're moving with some shared final velocity, and that's what we're trying to find. Now, the nice thing about this is that we know that momentum on this side, the initial momentum, has to be the same as momentum on the final side. It has to be the same. Momentum before equals momentum after. So what we need to do is, can we find momentum before and after? And the answer is yes, we can. So let me just get rid of this for now. If I look over here on the before side, the nice thing is that we have kind of a gift. Mass 2 is not moving, and so that means it doesn't have any momentum. Does mass 1 have momentum? It does. It has mass and it's moving, so that means I can find momentum for this first object. And what I'm going to do is I'm going to do the calculation right under each of the objects to keep everything nice and neat. Now this one I don't need any calculation because I know that it's not moving, so it doesn't have any momentum. So let's find momentum for the first beanbag. So P1 equals 3 kilograms times our 4 meters per second. That means this has momentum of 12 kilogram meters per second. If I compare the momentum for each object, I've got 12 kilogram meters per second, and I have 0. So the total momentum that I have, the total momentum before, is 12 kilogram meters per second. And since momentum before has to equal momentum after, I know over here on this side, it must be 12 kilogram meters per second. Both of these things are now stuck together in the after picture, right? I can see that I've got 3 kilograms stuck to 4 kilograms, so the total mass is now 7 kilograms. And I'm trying to find what the velocity is equal to. My equation for momentum, P equals mv. You can use algebra. We also have our triangle trick, P, m, and v. So if I want to solve this for velocity, it's just momentum divided by mass, and of course I'm trying to find for the final velocity. So this equation right here will give me my final answer. Let's put all the numbers in now. The total momentum, 12 kilogram meters per second, divided by our combined mass now, which is 7 kilograms. And so this will give us a final velocity of 1.7 meters per second. So there we go. We drew our picture, before and after picture. We found the total momentum before. We used that total momentum before in the after part to solve for our unknown. So give those a try, the ones that are assigned, and I will see you in class.